In this video, we're going to take a look at tangents to circles. So in this first definition, we need to write down a tangent line intersects a circle at exactly one point called the point of tangency. A line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So in this picture over here, the tangent is line AB, and it brushes by the circle and touches it at that one point we call the point of tangency. And then this radius is perpendicular to the tangent. And that will always be the case, that will always be true, and it helps us to solve problems with tangents to circles. So for example 1, it says determine if AB is tangent to circle P. In other words, we have to prove that this is a perpendicular relationship between tangent AB and the radius of the circle. And if it is a right angle and it's perpendicular, then the Pythagorean theorem would have to be true. So we just have to prove that a squared plus b squared does indeed equal c squared. And so treat it like 8 is our A and 15 is our B and 17 is our C. And we just have to plug it in and see if that makes sense. So we have to see, is 8 squared plus 15 squared equal to 17 squared? So 8 squared is 64, 15 squared is 225, and then 17 squared is 289. 64 plus 225 does equal 289, and so we know that AB is perpendicular to the radius of circle P, and that's enough to state that AB is tangent to the circle. So we would say yes. Let's try that same theory in example number 2. So number 2, we have 11 is our radius. It would need to be perpendicular with the tangent AB. And then notice the radius is also right here, so let's fill in that that would equal 11 as well. So we need to treat, let's say 11 is our A and 14 is our B. It wouldn't matter which one of those is A or B since we add those together. But let's say 11 squared plus 14 squared, so it's A squared plus B squared, and we're checking to see if that's equal to the C squared, which would be the total of that hypotenuse of our right triangle, if this is a right triangle, which we're trying to check for. So 5 plus 11 squared, because 5 plus 11 is the whole hypotenuse, which is like our C. So we're checking A squared plus B squared to see if it is equal to C squared. All right, so 11 squared is 121. Oops, let's put plus 14 squared is 196. 5 plus 11 is 16, and 16 squared is 256. So 121 plus 196 is 317, and that is not equal to 256. So therefore, we are not able to prove that this is a right angle and that the radius is perpendicular to the tangent, so we would have to say no for this example. All right, let's look at some more examples of what can happen with tangents to circles. So for example 3, it says, if JK is tangent to circle L, find X. All right, so if it is tangent, we know this is a right angle, making this a right triangle, and we can use the same idea we used in example 1 and 2 to help us solve the problem. Notice we have a radius equal to 10. So we could fill that in right here for this missing piece of our hypotenuse. So we could say A squared plus B squared equals C squared again. I'm just going to say A is 10, so 10 squared plus B I'm going to use is 24. And you can certainly reverse those and that would be okay. And then C is going to be X plus 10. So 10 squared is 100. 24 squared is 576. And then that's equal to X plus 10 squared. So I get 676 equals X plus 10 squared. Instead of foiling X plus 10, it's going to be easier to go ahead and take the square root of both sides. and it'll simplify much easier. So I get the square root of 676 is equal to 26, and the square root of x plus 10 squared is equal to x plus 10 by itself, and then I can just subtract 10, so I get x equals 16 for number 3. And that's all I needed to do. All right, for number 4, we just have to see what we're given, and we're still trying to solve for x. So notice 11 is the radius, and that would also be the length of ML. And so we can still set up the Pythagorean theorem, and we have x squared as one side, so that's like our A or B. 11 plus 11 is like A or B, it doesn't matter which one. But that would be a total of 22 squared equals the hypotenuse squared, which is like our C, is what we call it. So that'd be 25 squared. All right, so we have x squared plus 22 squared, which is 484, equals 25 squared, which is 625. And so let's just solve for x. So we need to subtract the 484 from both sides. So we get x squared equals 141. Take the square root of both sides. So we get x is the square root of 141, which is approximately 11.87. All right, let's take a look at number 5. I don't know why that little star is there. Just ignore that. So we have, let's see, x is our radius. That is perpendicular to our tangent, JK. And then if x is the radius, that's also the length of this radius over here, which we need for our hypotenuse, because this would give us a total now of x plus 10. And then we can set up the Pythagorean theorem again. So we have x squared plus 20 squared equals x plus 10 squared. And let's just simplify. So we have x squared plus 20 squared, so x squared plus 400. And in this case, I do want to go ahead and FOIL x plus 10 squared. So let's do x plus 10 times x plus 10. First would give me x squared. Outside is 10x, inside is 10x, and the last times last is 100. So I get x squared plus 20x plus 100. And remember, you could also have used the box method if you like that method to FOIL. That would also be fine. All right, and so let's continue on with simplifying and solve for x. So on both sides, we have x squared. So if we subtract x squared, they're both going to cancel or go away. And we can reduce our equation down to 400 is equal to 20x plus 100. So we're just keeping on solving for x. Let's subtract 100. So we get 300 equals 20x. And then just divide both sides by 20. And we get x is equal to 15. All right, so let's look at another property that tangents have when we have tangents to circles. If two segments from the same external point are tangent to a circle, then they are congruent. So see, if you have tangent AB and tangent CB and they meet at a point, they are congruent. And so that's what's stated right there. And if a polygon is circumscribed around a circle, then all the sides are considered to be tangents to the circle. And that's going to help us solve the next couple of examples. Okay, so for the next one, we want to find each value or measure and assume in the pictures that the segments that appear to be tangent are tangent. So for number 6, we want to find x. We can assume that AB and CB are tangents because they look like they are tangents, and they said that that's okay to assume. And so then we would know, since they meet at a common point, that they are congruent. And then we could just set 5x plus 23 equals 8x minus 19 and solve for x. So let's subtract 5x from both sides and bring down what we have left. So we'd have 23 is equal to 3x minus 19. So let's add 19. And that gives us 42 is equal to 3x. and then just divide both sides by 3, so we get x is equal to 14. And that's all we need for number 6. On number 7, we can just say that ST appears to be tangent, and SU also appears to be tangent, and we're given the lengths of those, so we can set those equal again. Since they meet at a common point, they would be congruent. So we can say 10x minus 41 equals 4x plus 7. And once we figure out what x is, we want to find SV. So let's keep that in mind. Okay, so first we're going to find x. Let's subtract 4x from both sides. So we get 6x minus 41 equals 7. So we can add 41. So we get 6x equals 48 and divide by 6. So we just get x equals 8. But that's going to help us to figure out what SV is equal to. So SV is the hypotenuse of either one of these right triangles. And we have the side that's the radius of the circle. They labeled that as 17. And that's going to help us be able to figure out SV. So it looks like the 4x plus 7 would be an easy place to plug in the x value we found. So I'm going to say 4 times 8 plus 7 is 32 plus 7, which is 39. We know the radius of the circle is 17. Let me put that in green. And we can solve to figure out the hypotenuse. All right, so we just have to say that it's a squared plus b squared will give us c squared. And c is the SV that we're looking for. All right, so we have 17 squared plus 39 squared would equal c squared. So 17 squared is 289. 39 squared, let's see, 39 squared is 1,521. So let's add that to the 289, and we get 1,810. And then we just need to take the square root of that. And so we end up with 42.54 approximately equals our C, which is the same thing as SV that we were looking for. So we could say SV is equal to about 42.54. Okay, so let's look at this last example for number 8. We want to find the perimeter of quadrilateral PQRS. And remember from the properties we just looked at that a polygon is circumscribed around a circle. If that's the case, all the sides are tangent. So if all the sides are tangent and they meet at a common point, then each one of these little corners has equal segments coming, or equal tangents coming out of it. So like 27.1 would also be the length of this little piece right here. And so then you could do some math and say 52.5 minus 27.1 leaves you with 25.4. So if you know what's left over, then you know that this corner would be 25.4, and that would equal the one right beside it, because those are tangents that are meeting at the common point S right there. And then these first two met at the common point of R. So with the ones that meet at P, these would both equal 23. And so then you could do, we could do 37.5 minus 23, which leaves us with 14.5, which would be our last corner over here. These two tangents meet at Q, and they would both equal 14.5. So let me put some more tick marks here. So those are congruent. And then 1, 2, 3, 4 tick marks, because those are congruent. So each set of tangents that are in the corners of this quadrilateral would be congruent. And then we would just need to do the math to add all that up and get our final answer. So I'm going to say 2 times 23, 2 times 14.5, 2 times 27.1, and 2 times 25.4, and add all that together. And so you should get the total perimeter is just equal to 180. All right, so that's it for this set of notes. Thanks for listening.